Welcome everybody to the statistics topic of correlation and linear regression. In this video, we cover three main objectives. First is to go through the least square principle, which gives us the equation of the line. The second is to go through the correlation analysis and figure out what the coefficient of correlation R and coefficient of determination R squared tells us. And the third is to go through the regression equation, which also gives us the standard error of the estimate. All right, so least square principle. For this particular objective, we see that in the regression analysis, the objective is to use the data to position a line that best represents the relationship between two variables. Okay, so now we can see this easily when we do a scatter diagram, which we'll have an example in Excel, and we'll create the scatter diagram for it. So the least square principle is trying to position a line that is best representing the relationship between two variables, x and y. So the scatter diagram in Excel will do this. We'll be putting the best, well, let me change the color here. The best possible line that represents the relationship between your x, which is your independent variable, and the y, which is your dependent variable. Okay, so which one is the best line? Well, Excel will do that for us, so we don't have to do it by trial and error. Now, the least square principle is a mathematical procedure that uses the data to position a line with the objective of minimizing the sum of the squares of the vertical distances between the actual y values and the predicted values of y. What is this saying? Okay, so when we do the scatter diagram, and again, Excel will do the line that is best for the data that we have. What we're doing here is we're trying to minimize the distance between the line and any possible, the distance between each data point and every possible line. And Excel will get the one that has the least amount of distance between the data points and any particular line. Okay, from once the line is figured, then we will get what is called the equation of the line. Now, different books have different letters for the equation of the line, but basically your y is your dependent variable. Okay, the a, or on the equation of the line, the number that is alone by itself is the y-intercept, which means is the value of y when x is equal to 0. Okay, if I put for this x, if I put a 0, then this goes away. Here, this is the value of y when x equals to 0, the y-intercept. If I put a 0 for this x, then this goes away, meaning y equals a. A is the y-intercept, okay? The y-intercept. All right. What else is in this equation? Well, we have this b. Whatever multiplies the x, whatever number is multiplying the x is the slope, okay? The slope could be positive if the line is going up, and the slope could be negative if the line is going down. So in the scatter diagram, you can visually see whether the slope is going up or down, and then the equation of the line will tell you the sign, okay? Positive if it's going up, and negative if it's going down. The x is your independent variable. Now, in the scatter diagram, as I mentioned, is a graphical tool that shows us, portrays the relationship between x and y, okay? Where you have your x is your independent variable, as I mentioned earlier, and the y-axis is your dependent variable. So what happened first, the chicken or the egg? First, you will have x is the one variable that you cannot control, and according to x, you're calculating y, okay? So now, for example, I'm sorry, let me go back here. So when you figure out, when two variables are given to you, you need to figure out before you start getting your scatter diagram, which one happened first, okay? Which of the two variables you're given is the one, which one controls the other, okay? So you need to figure out which one is your X and which one is your Y. Now, our second topic is correlation analysis, okay, which also tells us the relationship between two variables, X and Y. But so is a different way to tell the same story, okay? The correlation analysis is a group of techniques to measure the relationship between two variables like X and Y. Now, this is besides your scatter diagram. So you will do the scatter diagram plus you will get a correlation analysis. They both will tell you the same story, okay? For example, does the number of hours students study for an exam influences the exam score, okay? So in here, we have exam score and hours a student study. So which one happened first? So a student studies first, okay? First students study and then they take the test. So whatever happened first is your X. Whatever happened second is your Y, okay? You need to figure out first which one is your X and which one is your Y. Otherwise, you'll flip the information and you'll get the opposite of what you were supposed to get. So you have the correlation analysis that will give us the correlation between X and Y, and then you also have the scatter diagram in which you can visually see the relationship between X and Y. Now, in this correlation analysis, we get two different data points or two different numbers. One is the coefficient correlation or correlation coefficient. Now, the coefficient of correlation R is represented by the letter R. Is a measure of the strength of the linear relationship between two variables. Which two variables? X and Y. All right. Now, the coefficient of correlation coefficient R goes all the way from -1 to +1. You don't have anything above 1. You don't have anything below -1. 0 means no correlation, okay? So between -1 to 1. 0 means no correlation. So when you get the coefficient of correlation, a number of -1 or a number of +1 means perfect correlation. +1 or -1 is perfect correlation, but one will be a positive perfect correlation and the other will be the negative perfect correlation. Again, 0 means no correlation. All right, so now what are the numbers in between? Well, anything that is half, whether it's positive or negative, means moderate, okay? Nus. Now, any number bigger than 0.5, let's say, like 0.6, 0.4 is your moderate, whether it's positive or negative. And then if you're looking at something that is, let me put it here, from 7.7, whether it's positive or negative, onwards, you're looking at strong correlation, okay? When you have your 0.3s, 0.2s, and getting closer to the zeros, whether it's positive or negative, you're looking at weak correlations, okay? So if for this particular graph, this is a scatter diagram, if I put a line here, let me change the color of my line. If I put a line here, you get to see that there's very little distance between the data points and the line. So that will be a strong positive correlation. The line goes up. In the graph in the middle, okay, I'm going to put a line here, and you get to see that there's a little more distance between the data points and the line. Okay, so the more distance, the weaker a correlation is. Okay, and for the first one, well, it's more like a cloud. You can put a line maybe here. You can put maybe a line here. You put a line here. There's really not line that will give us a good, let me put one here. There are data points that are really far away. So this is the first The first graph is one that has a very weak correlation. So this one is, or no correlation, very weak, close to zero. This is weak because there are a lot of data points, and this one will be something that's strong. Now, again, the correlation coefficient R gives us a number. Okay, it gives us a number, and based on this number, we can say whether a correlation is perfect, negative or positive. Correlation is, it has no correlation if it's zero, or whether it's weak, moderate, or strong. The closer to zero, the weaker it is. The closer to one, whether it's positive or negative, the stronger it is. All right. From the regression analysis, we also get the coefficient of determination R squared. So I can go from R to R squared, from R to R squared. How do I do it? By squaring my R. Okay. All right. By definition, the coefficient of determination, R squared, is the proportion means percentage, the proportion of the total variation in the dependent variable y that is explained or accounted for by the variation in the independent variable x. And like I mentioned earlier, is the square of the coefficient of correlation, is the square of R. Now, when you square a number, if I had an R equal to negative 0.2, for example, and I square it, then this negative goes away to positive. So R squared does not have any negative numbers. R squared goes from 0 to 1. No negatives for R squared. There's no sign to it. Since there is no sign, it doesn't give me a direction. Like the slope gives me a direction. If it's positive, the line is going up, and if it is negative, the line is going up. The coefficient of correlation also gives me a direction, positive or negative. Here, I don't have a direction. So if you're having the graph, you have to see the direction, because R squared will not give you. Okay, so coefficient of determination tells us the proportion, the percentage of the variation of y that can be explained by x, okay, from 0 to 1. So 0 will be an equation that has very poor fit or no fit at all, and the closer to 1, the better the coefficient, the better the regression is. The closer to 1, the better the fit is. So you have 0, very poor fit, and 1 will be the perfect fit. They both tell, you know, the coefficient, the regression analysis or the scatter diagram tells you the same story. Now, third way to look at the same x and y is the regression analysis. They each tell you a different way to explain the information between x and y. In the regression analysis, we estimate one variable based on another one. So we estimate the y based on the x. The variable estimated is a dependent, just like before, okay? And the variable used to make the estimate or predict the values of is called the independent variables x. Same story. Now, the relationship between needs to be linear for us to have a regression analysis, which in the scatter diagram, that's what you see. Okay. Independent variables must be interval or in a ratio scale. The scatter diagram does that for you. The regression equation is an equation that expresses the linear relationship between two variables x and y. So this is the same thing that we get with the equation of the line. Okay, so now how is this a little bit different from what we've seen before? The one thing that we get that we don't see before is the standard error of the estimate. The standard error of the estimate is only in the regression analysis. Okay, so in the standard error of the estimate is a measure of the dispersion. The dispersion is the distance or the scatter of the value around the line of regression for a given value of x. So now, The standard error of the estimates, it's in the same units as your y, as your dependent variable. So whatever your units are for y are the same units for the standard error of the estimate, okay? And it is based on the square deviations from the regression line. What does this mean? Let me go back. The small values, the smaller the standard error, the closer the data points will be to the line. So this is another way to tell you how far or how close each of the data points are to the particular line, regression line. Okay, so you obviously want a standard error that is as small as possible. The smaller the error, the better the line will be, or the equation is. So they all tell you there are three different ways to say, to look at the relationship between x and y. One is you look at your equation of the line, and the equation of the line is via the least square principle. And the scatter diagram in Excel shows you that. Another way to look at the relationship between x and y is through your correlation analysis and look at the values for r and r squared. And the third way to look at your relationship between x and y is through the regression equation, which, technically speaking, tells you the same as the equation of the line. Plus, it also gives you the standard error of the estimate. It tells you how far, or how far or how close the data points are to each line. So from this, all three tells you the same story. So let's have a quick example here, and we'll do it in Excel. The City Council of Pine Bluffs is considering increasing the number of police in an effort to reduce crime. So police people compared to crime. Before making a final decision, the council asked the chief of police to survey other cities of similar size, to determine the relationship between the number of police and the number of crimes reported. The chief gathered the following information. All right, so we're going to make this decision based on the cities here: Oxford, Starksville, Danville, Athens, blah, blah, blah. How many do I have? 1, 2, 3, 4, 5, 6, 7, 8. I have 8 data points here. 2, 4, 6. I have 8 data points. And from these cities, I am gathering how many police people they have in each of these places compared to the numbers of crimes that they have experienced. So before I go anywhere else, what happened first? Are you having police first or the number of crimes? Now, on the exercise, it's telling you also we're having a survey to determine the relationship between number of police and number of crimes. So police comes first, and then you're seeing whether the number of police people or cops has any influence in the crimes that they have, okay, in this particular 8 towns. Now, we're going to have different questions to answer as we go along. First one, which variable was the dependent variable? The dependent variable is your y, okay? And which one is your independent variable? Independent variable is the one that you don't, that drives the second one. The independent is your x, okay? So if you are having issues, this is a hint. Which of the following makes better sense? Cities with more police have fewer crimes, or cities with fewer crimes have more police, right? So obviously, as we see here, cities with more police have fewer crimes. So what happens first? Police. The X is the number of the police people at particular towns, and then your Y will be the amount of crime that each city has. Okay, let me try to do the best possible writing here. This is the best possible writing. Police, and then you have your Y is equal to your crime. As best possible with the little electronic pen. All right, let's draw a scatter diagram from this. So I have Excel already open with this data point here. Okay, here it is. And one thing to notice is that I don't need, when you're given here, I don't need to know the cities to do the math. I only need to know which one is my X and which one is my Y. So ignore this. Okay. All right. So let me get out. Let's go to the Excel here. And I have my police and the crime. So again, we set the police. I'm just going to put a color here. Police is my X. And we set the number of crime is your Y. All right. Scatter diagram is in your insert. Insert. And the scatter, you have many choices for the graphs. The scatter diagram is right here. As you know, if you don't know which one it is, put your mouse on each of the graphs and it will tell you what it is and a little explanation. So you want the scatter diagram, okay? Oh, well, I didn't highlight any of them. So let me highlight my X and Y. Here we go. And now I can click on it, okay? And then you have many choices also. Okay, see, I haven't clicked. I'm just hovering on each of the choices. So I'll go on the first one. Okay, I'll just click on the first one and I have there my scatter diagram. Okay, so now I know that, you know, I wrote the question, so I know that one of the questions will ask me for my coefficient of correlation and coefficient of determination. Plus, I also need the equation of the line. So to get all of that, a quick way to do it is to go into the quick layouts and go for, you know, you have many different ways to represent, display the data, right? Again, I'm not clicking, I'm just hovering. Go to the one that has an FX. FX means function for Excel. You want to, if you want to keep your legends, you know what each of the data points means, the number of crimes, and the dots means is a linear regression. You can do that. You can make this bigger, a bigger graph like this, or you can also click here and delete the legends if you want to delete them. Then this will give you more room. However you want to do it is up to you. The important thing from the fx is that we get the equation of the line and we get to see the dots here going down. Let me see, I can also this here is the line of best fit. That's the line that minimizes the distance between each of the data points and a line. Okay, so now this is my equation of the line. The equation of the line is right here. Okay, and it also gives me my coefficient of determination. All right, so the exercise asked, or question B asked for the scattergram, which is there. Okay, so you can stop inking. You can, you know, click on a particular graph. See, if I click outside, I'm not in the graph. If I click here, I'm in the graph. You can do Control C and copy it somewhere if you need to copy it. But anyhow, I'll just leave it there for now. And it tells me to draw the scatter diagram, which we've done. Okay, determine your correlation coefficient. Correlation coefficient is R. Okay, I've got an R square from here. I have my R square. So there are a couple of ways to do it. So R, okay, it's asking me for R. Fine. That's what it's asking me for. But I actually have R square. Okay, where do I get the R square? From here. And it's 0.7646. Now, we can get R squared from R by squaring it. How do I get? Okay, so I have R squared. I need to get R. So I can get R by doing the square root of R squared. So let me show you a couple of ways to do it. One is you have, I just typed it, and I'm going to put on the cell below equal. Equal means you're starting a formula in Excel. So equal SQRT means square root. I open up parentheses and I click on the number that I've typed above. You can just go ahead and type the number there. It's up to you. Enter. So the R, which is the coefficient of correlation, is 0.8744. Okay, so we want it here. Coefficient of determination equals 0.8744. Is that what we got? I forgot. 8744. Yes, 4 decimal places is fine. So this is what we get. All right, fine. Then interpret the correlation coefficient. What does this mean? Okay, we saw earlier 0.8744. We saw earlier here that the closer to 1 or -1, the stronger it is. In this case, let's go back to our data point. We also said that r squared has no sign. Now, I know that the line is going down. So in this case, just by looking at it, coefficient of correlation can be positive and can be negative. Okay, a positive correlation will be a line going up. A negative correlation will be a line going down. In this case, let's go back and see our scatter diagram. The line is going down, which means this is police here, okay, and this is crime. So as the number of police increases, the number of crimes decreases. So in this case, we have a negative relationship here. So this R here is actually a negative R, okay? 0.8744. But remember, I did it by square root. So this one here, the answer should be a negative R because the line is going down. All right, so now what does this negative 0.8744 mean? Okay, and so I have this is a strong negative correlation, and it means that the more police, the less number of crime in a city. Okay, according to this number, according to the 8 data points that we have. Okay, all right, now what is the R square? Okay, R square was given to us directly here. R square is 0.7646. R square, 0.7646. So let me type it here, and this is R square equal to 0.7, and I forgot 0.7, 646. Now R squared tells us R squared tells us here the percentage of y that can be explained by x. All right, so proportion is percentage. So to get percentage, you multiply R squared by 100, and that means that 76.46% of y, well, what's your, so of y, which in this case is, let's go back, y is your crime, okay, of y, which is the crime, can be explained by the x, and the x for this particular exercise was the number of police. Okay, now 76%, this is not 100. So out of the 100%, 76% can be explained, 76% of the crime can be explained by the police. So I also get to say how much is not explained by the police, okay? So if I do 100 minus 76.46, okay, and I'll do it here in Excel so I can do Excel equals 1 minus, and I just click here, it gives me 20.54. This is what is, you know, if I add both, I will 100%. So 23.54. So this is equal to 23.54%. 23.54, yes. 23.54% of crime cannot be explained by police. And I'm running out of space, I know. But anyhow, let me get this bigger for you here. Whew, there it is. Okay, so those are getting the scatter diagram and figuring out the R, what the R means, and R squared, and what it means. Okay, and this I didn't write it here earlier, but in this was your X is police and your Y is your crime, which we did earlier. Okay, what else do we have here? Determine the regression of equation. The regression of equation is the same as the equation of the line, okay, which we have here. So I'm just going to grab it from here and copy it. Control C, and I'm going to bring it here. Okay, that is my regression line. Regression equation, regression line, same thing. The slope also has a direction. It's negative because the line is going down. Now, interpret the values of the y-intercept and the slope. Which one is which? Whatever multiplies the x, which is 0.095, this one right here, whatever multiplies the x is the slope. Okay, so I'm going to put here slope is this, and it has a negative that I didn't grab, and then the slope, and the y-intercept is a number on its own. Okay, so y-intercept, and you need to know which one is which. Otherwise, just doing it does not mean that you know which one is which. The slope is negative, and I have written it in red, so let me put it in red. Estimate the number of crimes when there are 20 police. Okay, so I have my equation of the line here. Okay, oops, I'm going to undo. Okay, Control C. I'm gonna just paste it here, my equation of the line, and I'm gonna separate the x and the y below. So y and x. And just I don't get confused, y is a crime. I'm just typing right now. Okay. And x is police, number of police. All right. So I want to know, this question here is, estimate the number of crime when police are equal to 20. So when x is equal to 20, what is my number of the crime? So I'm gonna put in these two cells the equation. So the equation is y equals, to open an equation in Excel, you start with equals, and I'm gonna type the equation negative 0.9596 times x. I'm gonna type x here. So I'm just clicking on the empty cell. I will put the number later. Plus 29.388. So here is this equation written here. Let me show you which equation. This equation. Okay. All right. Now I don't have any x's. I'm gonna type the x number there. I'm gonna just put color. So if I type here 20, which is what the question is saying, then it's good. The equation is gonna say, okay, so x, for me, x is located in U12. This is U, and this is 12 is here. So it's a location. This U12 is a location. So location I type, so types whatever is in U12, which is 20, plus 29.38. And remember, the slope was negative. So there it is. Now, if they were to tell me, what about if we put 5 police? Okay, this is 24. If I have no police, then it's 29, which is your y-intercept, right? And if I have 40 police, right? Ooh, negative. Negative crime means no crime, okay? So in this case, I've asked for 20. What is the number of crimes when they have 20 cops? That is 10.196. So estimate the number of crimes. Estimate the number of crimes. The number of crimes is, so crimes is equal to 10.196. Okay. And here, so that's the answer for HI. Estimate the number of police to have 0 crimes. All right. So what is the, so not negative crime put 0. What is the number of police? Police is your x. To have a y equals to 0. All right. So I am changing the question. In this one, I'm asking, I want to have, let me get my pen. I want to have y equals 0. Okay, so what is my number of police that I should have? So the question is backwards. Okay, now for that, we use what is called solver. So data, solver. If you don't have it, you can go to File, File, Options, Data Add-ins, and somewhere here you have solver. Later on, we'll use Analysis Toolpack. If you don't have it, it's here. Okay, and then you say Go, and then you find this little window, you make sure it's clicked, and then you say OK. Okay, now for those that have Apple, you get your mouse at the top, all the way to the top, and there is will be a new window coming down, and in that one you look for Tools. Then you go on Tools, you drag down, and they will be somewhere there for Excel add-ins or just add-ins. So just like I had it here in Options, and there was an add-ins for, and then you follow the instructions that I just gave earlier. For Apples, you go at the top, click on Tools, and then add-ins, and then you follow the same of finding it, clicking it, you know, and then adding it. All right, so solver. What are we solving for? What is my objective? My objective is that Y, which is this one. My objective is that my crimes have a value of 0 by changing the number of police. Police is here. Okay, again, I'm going to figure out in solver. The objective is that my crime, my formula, which I typed here, has a value of 0, and I'm going to change my number of police. I only have control over police, okay, by changing my police. I say solve. Wait, I did something. What did I do? Say okay. All right. Oh, I'm seeing. I clicked it a couple of times. Okay, close. I'm going to just close it. Okay. Solver, here we go. Objective is that my Y is equal to 0 by changing my police. I say solve, and it will be here. You say okay, and the number of police is 30.6. Okay, this right here means a very small number, 0.0000 whatever. So the number of police is 3.6. Here is police force should be equals to 3.62 police. Now, these are human beings, so you cannot really have 30.62, you will have 31. Standard of error, the last thing here. Standard of error, we get it from regression. Okay, regression you find in data analysis, which again, if you don't have, you add like you added solver, and you have here regression. Okay. And in here it's asking you which one is your Y. Y. Y is here. Number of crimes. And I've put the cell for a label here. X is police. And I've put here my label, the police. So I have it in a label. And it's gonna tell me where do you want to put the information. I click here, and when I click here, see, it goes to this section. Be careful, you have to come back and tell it, this is where I want it. And I'm gonna say just to put it there. Anywhere in Excel is fine. So this is my output. And we're looking for the estimate, the standard error. Okay, the standard error is 3.37. Remember, this is in the same units as your Y variable, which is crime. So what is the estimate of the error? Because I'm doing this only with 8 data points, 8 cities. So the estimate is error is 3.378. So what is the estimate error? Oops. The estimate error is 3.378 police. That is like, so you have like here the same as the y-axis, which is correct. So for example here, if the answer for this was 10, and it's like plus or minus 3.37. Okay, it's not, it cannot be exactly 10 because you're doing this based on a sample of 8 cities. So the bigger, here we got a sample of, where are my pens? We're doing all of this based on 8 cities. So the more cities we get, like if we were to get 100 cities, then we have an error that will be less. Okay, so this is based on 8 cities. So the standard error is 3.38 with 8 cities. You know, it's not an exact number because you don't have all the data points, all the cities in the world. And it's just a sample. And just to show you, you have also the R square here, 0.87 is here, and you have the this is yeah, the R, I'm sorry, the R, and the R squared is here, 0.76, which is here. Okay, so it's telling you the same story. You also have your equation of the line. Okay, blue here, I'm gonna put here the y-intercept 29.38 is the one that shows here, and then you have your slope to negative 95 is here as well. So you can get the relationship between x and y in three different things, 3 different ways. Okay, if you have just a scatter diagram, with the scatter diagram you get the equation of the line, and you also will get r squared. If you do the correlation from R squared, you can get your correlation analysis and get also the value for the correlation between X and Y, R. And if you do the regression equation, you will get also the slope and, I'm sorry, the slope and the y-intercept, and you will get the R squared, but you will also get the standard error of estimate because you're doing all of your correlation based on a sample. For the one exercise which we just did, sample size was 8. Okay, and for that you had a particular estimate, a standard error of 3.38, I think. The bigger your sample, the smaller the error. Okay, thank you so much.